lo tanto, el valor de la variable va a ser el opuesto del término lineal más menos la raíz de ese término al cuadrado menos el cuádruple del producto del término cuadrático por el independiente. Todo eso dividido entre el doble del término cuadrático. ¿Entendiste? No. Well, let's see if in English you do it right. Okay, let's start with a quadratic equation that looks like this. A number times x plus another number, all these raised to the second power equals another number. This is a quadratic equation, it's not written in the general form, I know, do not complain. But if it was written like this, then you could solve it without the general formula, just by doing the opposite operations. And it would look something like this. You take the square root on both sides, and that will lead to the separation into two solutions of the quadratic form of equation. Then you subtract the b, which you can because you can always do the same operation on both sides. On this side it would like disappear. On the other side you would have to write it subtracted from the rest. And at the end you divide by the coefficient of the variable. All of it, of course. I'm doing it right, do not complain. Divided by this coefficient. It looks pretty much the same, huh? What's the difference? The a would have to be these 2a. The b is the same. And the c, this capital C, is like all this. The b squared minus 4ac, and this would change into 2a. So if we have a quadratic equation written as the square of a binomial, but with these coefficients, which are numbers. All these b squared minus 4ac is just numbers, right? Then by solving it, you would have here 2a plus b equals the square root of the discriminant b squared minus 4ac. This one's the same, this one's a 2a, and the c is b squared minus 4ac. This, I hope you can see it all. Then you would get the general formula divided by 2a. So what you need is to have an equation written like this. But how can you write an equation like this if you always have a quadratic equation written in the general form? So I'm going to convert these into the general form. I'm going to erase this part. How does this look in the general form? What do we have to do? We have to erase the parentheses and make it equal to 0. How do I erase the parentheses? Well, I'm going to raise this binomial to the second power. And maybe you know the rule. The first term to the second power, which is 4a squared x squared, plus twice the product of both. Twice 2 is 4, a times b times x, plus the square of the second term, equals the same, b squared minus 4ac. I simplify, for example, I have b squared and b squared, I subtract b squared from both sides. I subtract b squared from both sides and I get 4a squared x squared plus 4abx equals negative 4ac. I can simplify it further, they all have a common factor, 4a. I divide all the equation by 4a. Here the 4 disappears, from the 2a's I only get 1, ax squared plus the 4a disappears, bx equals minus c. I add c on both sides and I have ax squared plus bx plus c equals 0. So if you want to understand why is this the solution of a quadratic equation, a general solution for any quadratic equation written like this, then you only have to go backwards. So you have a quadratic equation. written in the general form. And you do some algebraic tricks, which you can do because they are right, they are correct, mathematically correct. You can subtract c on both sides. So first you subtract c on both sides. Then you multiply by 4a. And you get something like this. Then you add b squared on both sides. And then you recognize that this is a perfect square trinomial and can be factored as the square of a binomial. So you factor, and from this you can solve by doing the opposite operations, and you get the quadratic formula. Now the question is, why do you subtract c, and why do you multiply by 4a, and why do you add b squared? Well, you do it because you can. You do it because you know how it should look like. So this explanation of the general formula, it's a little bit tricky. But the objective is to have an equation like this one, written as the square of a binomial equal to some number that is written as all this, the discriminant. That's why you don't make it equal to 0, you leave the terms with the x here. Then the 4a is because you want this one to be the midterm of a perfect square trinomial, which is double of something. So it has to be at least 2 or 4 or 6 or any even number, any even coefficient would help. But if you have a 2, then when it's raised to the second power, it must be a 4. That's why we get this 4a. There's another way, which I'm going to explain next. The one in English or in Spanish. We did German already. It has square roots of big stuff, but it's correct. Let's see. So you have this for sure. A quadratic equation written in the general form. You wanted to solve it by doing the opposite operations. You would like to find the square root, but it's useless because then you will have the square root of this term. So what you have to do is to take the square root of a perfect square trinomial. But how do you know if this is a perfect square trinomial? It usually isn't. So you have to make it look like a perfect square trinomial. Okay? So the first thing we do is to recognize this as the first term of the perfect square trinomial. And disappear the c. Fathers also on this side. Now, in a perfect square trinomial, this is supposed to be a perfect square. A is the square of the square root of a. Now this one is supposed to be twice the product of this one times this one. Twice the product of the square root of a and this one that you don't know. How do we call it? Do you want a w? The square root of w. So this one would be like a w here. Good. So if the b is this, then what is the w? B divided by 2 times the square root of a. All these raised to the second power would be the w. So the w is b squared divided by 4a. So we put it here. B plus b squared divided by 4a. This is a perfect square trinomial. This is a perfect square of the square root of a. This is a perfect square. And this is twice the product of both. But the square root of this one by the square root of this one by 2, then you get b. That's the trickiest part. But if we want this to appear on this side, we also have to add it on the other side to keep the equation true. I'm gonna do here an addition of fractions. Now that's where we get tricky. I'm gonna multiply all of it by 4a. 4a times ax squared is this, plus 4ab plus b squared, oops, the x, plus b squared, the 4a disappears, equals minus 4ac plus b squared. Or if you want to turn it, it's b squared minus 4ac, which is the discriminant that you know. Be patient, we're almost done. You are like my students. I hope I had 42 pacifiers for my students. You already lost it. Okay, you don't want it. And that's where we get b squared and the 4a from. The rest is the same. I'm gonna do it again. This is a perfect square trinomial, which is the square of 2ax plus b to the second power minus, well, I'm going to b first. Minus 4ac plus b minus b squared minus 4ac. I'm going to take the square root, 2ax plus b equals the square root of b squared minus 4ac. You subtract the b, 2ax equals minus b, well here you have to take the both roots, b squared minus 4ac, and then you divide all by 2a. I don't know if you can reach this. And that's it. Do you like it? So this is hard to complete the perfect square trinomial. That's the clue, the key word. You complete the perfect square trinomial with this one. Why? Because the double of the product of the square root of this one and this one is b. And if you add this on both sides, and you want the denominator disappears, so you don't have to do addition of fractions, then you multiply by 4a. So you add the b squared and multiply by 4a to make this simple thing into a perfect square, and solve by doing the opposite operation. Thank you very much. Do you understand now? No. Good. Well, then at least say hi.